All right, here we go. First thing we want to do. In our foldables, we have been learning these shapes. Today, we're going to put those shapes together and have irregular shapes to find the volume of. So one of the first ones is like a silo, and you may have one of these on a farm. You may have seen one driving by. This goes on the back of your foldable, yes. I'm just writing on the white paper so it shows that better. And a silo is made up of a cylinder, and then the top of it is half of a sphere, yes. And you may see these on farms or driving in different places. Some of you may have one. Let's go ahead and label this. This is half of a sphere. So if you have only half of the sphere, what do you got to do to your formula at the end?
Divide by 2.
Okay, so let's make a note of that. Divide by 2, because that'll be our common error. And then we have a cylinder here. Let me go ahead and tell you that all the way across, so the diameter of this is 12 feet. And we will say the height, okay, is 17 feet. The height of your cylinder is 17 feet. And then the diameter, if it's the diameter down here, it's also the diameter up here, so that also relates to your sphere, okay? So the first thing when you have an irregular shape or a shape that's got a couple of different shapes in it, let's start with our formulas. Formula for the volume of the cylinder is pi r squared height, and then the volume of our sphere is 4/3 pi radius cubed. And then if you want to, remind yourself over here to divide that in half. So go ahead and work on that and see what you think. Get your numbers plugged in where they go. Yes. Okay, I had it in when I come in the room you were on. Okay. All right, now good. So go ahead and plug in what you think. All right, so let's see. You should have plugged in here pi times, is the radius 12?
No, 6.
Thank you. Times 6 squared times 17. Type that in your calculators, and what do you get rounded to the nearest tenth? What do you think, Adele? Okay, do you want to switch? All right, trade that out for her. You got what?
1950.
Yeah, that's what I got. 1922.7 cubic feet. Now you're not finished. Let's go over here and deal with the sphere, or the half sphere. Be 4/3 pi times 6 cubed, and then divide by 2 in the end. You should have gotten, let's see, 4/3 times pi times 6 raised to the 3rd power, and then divide by 2. What'd you all get?
452.4.
452.4. And then, what do you do to these two numbers?
Add them.
Yes, you add these two numbers together to get your final volume of how much this whole silo would be able to hold.
Oh, do you have a 2?
Yeah, on this right here, you had to divide by 2 because it was half of your sphere. That's the common error for students. So then add those together, and you should get an answer of 2,000. Yep, 375.1 cubic feet. What do you think? Easy?
Yeah.
It's time consuming, but it's not bad. It is not bad, but it is time consuming. Let's try another one. Let's talk about a roll of paper towels. So when you're thinking of a roll of paper towels, what shape is it?
Cylinder.
A cylinder. So let's draw ourselves a roll of paper towels. But do you realize that there's two cylinders involved?
There's a hole in the middle.
There's a hole in the center of your roll of paper towels. So, really, you have to take that out, okay? Or we could have this huge big pile of dough and it'd be a huge donut and you cut the hole out of the donut, okay? However you want to think of it. All right, you can think of it as toilet paper. We're gonna put measurements on it like that it would be a roll of paper towels. So, I would say the interior radius, the small radius inside, would probably be 1 inch. So I'm going to draw an arrow there. However, from here on out, the radius might be
So is that the diameter?
3.
Or the radius?
Radius. Did I say diameter?
No, I just couldn't.
No. Okay. Radius. So we have 2 radii. We have the small one, which is 1 inch, and then we have the other one, which is 4 inches. The height of your paper towels, how tall y'all think a roll of paper towels might be?
Like a foot and a half, something like that.
A foot? 12 inches? We'll go with that.
More or less.
Now, do we need to add in the brown roll, or do we need to take it out?
Take it out.
Yes, so we would be subtracting because it doesn't, your whole roll of paper towels the whole doesn't include any paper towels. It's completely empty. So we can't include that in our volume, okay? So let's do this. Let's have 2 different volume formulas. Power squared height, because both of them are cylinders. And let's plug in, you can call this one small and this one the large if you want to differentiate. So for the small one, you're talking about the brown roll in your paper towels. We say pi, the radius is 1 squared, the height is 12. Type that in your calculators. Do y'all agree? Maybe. We'll agree with that one. That's what we got for it. And then do the large, the whole piece. And see what you get. And then subtract your 2 pieces. I might get this one wrong. 603.2. Is that what you all got? And then I have to subtract these because I don't need the hole in the paper towels holds nothing. So I need to subtract my 37.7. So my volume would be, bless you, 565.5 cubic inches total. Yes, sir.
Wouldn't it be squared? No.
It's not, it's still volume. Volume. Okay, now what if they don't give you this? And you should still have room on your foldable. I'm going to write here. What if they just give you some other information? First of all, they'll tell you it's a cylinder, so write this down. It is a cylinder. It has a volume. You can write it on regular paper if you don't have room. The volume of that cylinder is 314 cubic inches. It will tell you that the radius of that cylinder is 5 inches. The height is unknown. So now we kind of have to work backwards, and we have to use equations and what we know about solving equations to figure out the height. And you had some of these in your IXL sections if you started on Q.28, okay, because these were on there. The first thing you want to start with always is your volume formula. If it tells you volume and it tells you what the shape is, start with that. Volume is power squared height for cylinder. Next, plug in things you know. Okay, so plug in V stands for volume, so that's going to go here. 314 equals pi. The radius, it tells us, is 5, so plug that in. We do not know the height, so it must stay in H. Now, this is exactly like solving a normal equation like what we've done all year. If I'm trying to isolate the H, I'm isolating the H, I have to get rid of these 2 other pieces. Right now, they're multiplied. So what's the inverse operation of multiplying? So divide. So if you divide on this side, what do you have to do on the other side? So here's how I do it. Okay, there's many ways we can do it. I'm just, instead of multiplying all that and seeing what I have to divide it with, I just say divide by pi times 5 squared. Over here, divide by pi times 5 squared. So when I type this in my calculator, I type in 314, divide by pi, hit your equal button, divide by 5 squared. I'm dividing by both of these, and my answer is, what'd you all get?
I got 4.
Yes, you should get 4. And that's the height. 4 is the height. So 4 what is the height? 4 inches. Do I have to cube it or square it or do something weird? No, because it's just how tall the cylinder is. The cylinder is 4 inches tall. That's all you need to know.
So you don't have to multiply in that third?
You do not. Try it and see if you don't get the same answer. You might end up with a slightly different answer because of your if you round.
I put 3.14 instead of 5.
Yep. And in some cases, it'll tell you in directions to use 3.14 for pi, or it might say use the pi key. All right, let's try another one of these. I'll try. So it did work, right, Chris?
Yeah.
Awesome. So now I'm telling you, look at the shape. Now it's a cone. All right, the cone says, here's your volume, 37.68. The radius this time is unknown. The height is 9 centimeters. Okay, so this one's a little more difficult. Start out with your cone formula. 1/3 pi r squared height. Okay, plug in what we know. We know the volume. Alright, we know that 1/3 stays. We know pi stays. The radius is unknown. It has to stay. Height we now know is 9. So, I know that I'm trying to isolate this. So I need to get rid of all this other stuff. So I just need to divide it all away. Divide by 1/3 times pi times 9. On this side as well as the other. Alright, let's see. Type this in. 37.68. We want to divide by 1/3. See what that equals. Divide by pi. See what that equals. Divide by 9. See what that equals. I have 4 equals r squared. Now, I'm not finished. That's radius squared. Do you remember when we did Pythagorean theorem and we had a squared or b squared or c squared? And we always had one last button to push to get my final answer. What button was that?
You have to.
The square root button. Yeah, the square root button, the button that looks like this. Because you can't have something squared and that be your final answer. So hit your square root button. And the square root of 4 is 2. And what unit are we measuring in? No, in this one? Yeah. So the radius was 2 centimeters. Okay? So it's kind of like you're working backwards. It's still doable. Just maybe a little more difficult. Okay, we're going to try a couple more before I turn you loose. I want you to try these on your paper. You do not have to draw the picture if you don't want to. This is one of each kind. This is an ice cream cone. It may be the largest ice cream cone anybody's ever seen because it is 7 inches in height. And the diameter of the ice cream, as well as the cone, is 4 inches. So that ice cream is 8 inches across. And the cone itself is 7 inches. So it may be a family cone. You go and you buy one, it's probably $40. Okay. So, you can get on new paper.
Or you can just do it in the middle.
Yep. Okay, so keep in mind, take a look right here, guys, for just a second. I put this in a little cloud because you only have half of a sphere. So don't forget that because what's on top is your big ice cream scoop, okay? So it's half of that. Once you get these done, you have to add because it's the total amount of volume of ice cream in that, okay? So see what you can do with that, and we'll come back together in a few seconds, and we will check.
Volume, it can't be like pounds or stuff like that.